Okay, good. So a conjecture is nothing more than an educated guess. And in science, we call that a hypothesis. This unit, we're going to start talking about logic. So what we're really trying to say is, how do you problem solve? What are some ways and some skills that you can solve problems that may seem a little bit more difficult? And one of the ways is called inductive reasoning. And inductive reasoning uses specific examples to make a prediction or a conjecture, meaning a pattern. So right here are some patterns that we need to follow. When they're talking about people from CSI, don't they follow a pattern?
Yes.
There's a certain procedure, and when certain things happen, other things occur. So right here, all an inductive reasoning is just a pattern. How can we follow through? So I'm going to give you a minute or two, and I want you to look at problems 1 and 2, and I want you to see what would come next in the pattern. Okay, very good. So we did problem 1 and problem 2. Problem number 1, most of you just saw those boxes. I want to know, did anybody think of it any different way? Like, this is 1 squared, this is 2 squared, this is 3 squared, so that means this one would be 4 squared. Because 4 times 4 would be 16, there's 16 boxes. 3 squared is 9 boxes. Okay? Right here, 1, 3, what you're doing is, how do I get from 1 to 3 and then 3 to 9? Each time I can multiply by 3. Patterns are sometimes very hard. Okay? I'm going to tell you right now, this is not one of my strengths in geometry. Okay, but what I can tell you is, you can do different things, like you can add, you can subtract, you can multiply, you can divide.
You can add and multiply too at the same time.
Sometimes you can multiply and add, very good, but also you need to look at exponents.
Exponent.
Sometimes those get you. On this one, we had times 3 all the way across. Sometimes the number's not the same, sometimes the number changes. So I want you now to try number 3 and number 4. Okay, good. On number 3, absolutely. So here, on number 2, we had times 3 all the way across. Here, my numbers changed. I'm adding. 1 plus 2 gave me 3. 3 plus 3 gave me 6. 6 plus 4 gave me 10. So the next one I would do would be add 5. Great job. On number 4, it was 9/5. But wait a minute, where did this 1 come from?
That's a whole. That's a whole.
Okay, but why does it fit in this pattern?
5 over 5.
It's 5 over 5.
Oh, 5 over 5. Very good. And what would be the next one after 9 over 5?
10 over 5.
Which is?
1 and 1.
2.
Which is 2, right?
10 and 1.
Yes.
So what they're going to do on patterns sometimes is to put it in a format with like a 1 and a 2 to try and throw you off.
Yeah,
So you just have to put it into a different format that follows along with the pattern. Does that make sense?
Yes.
Okay, good. Try number 4. Go ahead and graph those points. I want you to graph those points for number 4, and let's see what you can find there. All right, so somebody tell me what's a conjecture of some sort that you can tell me about this when you graph those 3 points.
It's positive.
Positive slope, very good. What else? Oh, they all are in a line. What's that called if they're all in a line? Collinear, very good. What else? The slope is 1. Okay. What else? What do you notice about the numbers? Graph another point and tell me what's that coordinate.
The next 0, 0.
Good. X and Y are the same. It could be 0, 0, right?
Mm-hmm.
They could be 8, 8. They could be 9, 9, and 10.
They just match each other.
Good. They match each other. X and Y are both the same value. So on this one, you would say that X is equal to Y.
X equals Y.
Very good. Okay, now go to the back side. Okay, I want you to draw a picture in your head. What does number 5, number 6, and number 7 represent? Because in here, our goal is to get you to be able to draw exactly what I have in my head. Okay, I want you to be mind readers. Can you do that? Okay, but some of you are struggling in here because what you're visualizing with a problem is different than what I visualize. When we do the segment addition, if you don't draw the picture, then you haven't visualized what they're asking you to do. So I want you to take a second, 5, 6, and 7, and draw a picture. Okay, so let's talk about these. This says that angle 1 and angle 2 form a right angle, right?
Mm-hmm.
Okay, so this could be one way. What about this? Would this be wrong? Does angle 1 and angle 2 form a right angle?
Yes.
Did it say anywhere that they had to be connected?
No.
No. Okay, well what happens if I draw it like this instead? Okay, what's different about this picture?
Oh, because it's complementary.
Good, these would be complementary. So if they would have told me complementary, it would be more precise about what kind of picture they wanted me to draw. Would you agree?
Yes.
Good. What about number 6? Is that okay?
Yes.
Is there another way that I can draw vertical angles?
Yes, like this.
Okay, well hold on. Yes, this is a vertical line, right? But when we're talking about vertical angles, there's ver words. Vertex,
You have to
Vertical.
get X.
and vertical has 2 different meanings. Vertical, like a basketball vertical, we're jumping up and down, and that's what you're thinking of, right? Vertical angles in math mean that they're across from each other. A vertex is a point at the corner of an angle. Are you with me? So there's a lot of ver words, and some of you just went, oh, that's why I got them all mixed up all the time. Okay? So those are the kind of things that we're going to talk about. But be careful, because here vertical does not mean up and down like a basketball jump. Okay? Vertical means that they're across from each other, and that these 2 right here are going to be the same. They're congruent. Okay? And then a lot of you, most of you, drew this on your paper. Right? Most of you drew this on your paper. This is going to be more accurate right here. All we need to do is make these 90 degrees. This one, I would actually put the E on the outside and the F on the outside because they're talking about this vertex right here. Okay? Now, the reason why this one's not going to be as accurate is because E and F are talking about this point right here. Can that one point be named E and F?
No.
No. Are you with me? Yes, they're both 90 degrees, and I understand what you were trying to think in your head. But the problem is that I can't have one point representing both letters.
Yes, you can.
So I need to separate those out. Are we okay? Good. A counter example.
Pablo, Tom.
A counter example proves a statement false. I'm going to tell you right now that y'all are very good at this. Because any adult, when they talk to you and they ask you certain questions, you do everything in your power to try and prove them false, correct? When your mom and dad say something to you, you're going to try and figure out a way to put a spin on it and come back at them, right? Okay, did y'all hear that Sally is dating Johnny?
Yes.
Well, but on Saturday, I saw Sally and she was with Tommy.
Who's Jimmy?
He said, who's Jimmy?
Nobody said anything about Jimmy. I said Johnny.
Who's Johnny?
Okay, but you do this in the hallways, don't you?
Yeah.
And you're like, I saw
Gossip.
Sally, she was with Jimmy. But what you didn't know was that Sally was with Jimmy buying Tommy a present because his birthday's tomorrow.
Yep.
Okay, but you do this, don't you? And you're really good at it to try and decide if something's real or not.
Yep.
Okay, but you know you think it, right? You may not get involved with it, but I promise you, all of you think about the comments that people make, and you're like, well, that's just dumb. That can't even be the case. Are you with me? Okay, so a counter example is just proving somebody false. So I want you to take number 1, and I want you to draw this picture. Okay, and then I want you to say, is the conjecture they gave you true? So you're going to take the given information right here, and you're going to draw a picture of just this right here. And then after you draw your picture, you're going to say, will this work with my picture? And then I want you to come up with and see if you can find a counterexample. Well, can I draw it differently to make it false? Okay, so I'm betting that most of you drew a picture that looked like this with A, B, and C. Everybody agree? That's pretty much what you drew?
Yes, ma'am.
Good. And then the conjecture says that AB plus BC equals the whole thing. Is that true?
Yes.
So is there another picture
Yes.
that I can draw that they are still collinear that does not work?
Yes.
How?
CA.
B, C, A. So you say if I draw B, C, A. Are they still collinear?
Yes.
They're still in a straight line?
Yes.
But if I come over here and I look at AB is the whole thing, plus BC. So if I add those two red lines together, do they give me the length of AC?
No, if you subtract it.
This right here. Okay, good. If I subtract, but now I've changed this.
Yeah.
Okay, so this right here is an excellent counter example. You just said that I can draw this information. This is what happens when you're doing word problems and you get stuck sometimes. It's because you think you're drawing a picture that represents this stuff, but then you go to and get a different answer. Are you with me? When you set a problem up wrong, okay, then you're actually trying to provide that counter example, and it doesn't work, or you get a different answer. Sometimes it's true. Sometimes you can do something in a different way, and you still get the same answer, right? But when you do something a different way and it's wrong, okay, then we can't get to the same spot. If I can visualize the same thing. Today outside it's sunny. Is that true or false?
False.
Is the sun shining outside today?
Yes.
Yes, the sun
It's
is.
not.
Yes, it is.
It is.
raining.
It's just
The clouds are just covering the sun up.
Nope.
The sun is shining, but the clouds are just covering it up.
You see the sun?
Sunshine. Okay, try number 2. All right, so it says that angle R and S are supplementary. What does supplementary mean?
That'd be an angle 180.
That equals 1.
Okay, can I put these two angles together? So what you're saying is I can draw it like this and label this point right here R and S? No. Okay, so that means I have to have two angles. One of them is R, and the other angle will be S. Maybe this is 80 degrees and this is 100 degrees. Everybody good?
He said it's congruent.
What's congruent?
The two, T and S.
Oh, but then the next thing is that I drew R and S and they're supplementary. R and S, they're supplementary. And then it tells me that R and T are also supplementary.
So that one got to be 82.
So this one also has to be 80 in order for those two to be supplementary. So is it true that T and S are the same?
Yes.
Okay, is there a way for me to draw this where that wouldn't be true?
Yes.
Well, I can't put them together. I can change the angle measures,
Yeah.
okay, but it would still be the same.
Still turn out.
Okay, so this right here, this is a false statement because I was able to prove a counterexample. This one, there's no other drawing. I can't change it, so that makes this a true statement. There's no other way to draw it according to the given information, so it makes it true. I want you to try number 3 and number 4. I want you to try number 3 and number 4. Okay, again, remind me, what does supplementary mean?
Equals 180.
180. Can these two be touching?
No.
Why not?
Because there's two different angles.
Good. Do I have the same vertex or different vertex?
Different.
Different. So I have to have two different angles, A, B, C,
And DFE.
and D, E. Again, maybe this is 110, which means that this one would be 70 degrees. So the question is, are A, B, C, and D, E, F on a linear pair? What is a pair?
Two
Two what?
are the same.
Two angles that make a line. Are these two angles and do they make a line?
No.
No. Remember, a linear pair must be connected. So what that means is I can't draw this any other way, so this is a true statement. Because I can't make a counterexample. It's true. It's the only way I can draw it. Oh, well, it's false because it doesn't make a linear pair, but I don't have a counterexample. They're not connected. Does that make sense? Okay, and what about number 4? DE. What is that symbol right there? Which means what? 90 degrees. Is angle DEF a right angle?
Yes.
Can I draw it differently?
Yes. I believe so. I don't know. I'm just saying.
Well, I could draw it like this,
You draw it facing the other way. Draw it upside down.
but it's still 90 degrees.